All right, everybody, welcome back to the Unit 1.2 review video. This is part 2 that's going to cover solving variables on both sides. And remember, that trick we remember is filthy dumpsters contain very nasty stuff. And the dumpster, the filthy part means fractions, right? We need to take care of our fractions first. Dumpsters is distribute. Contains is combine like terms. On either side of the equal sign. Contain, not contains, is variables on one side. Nasty stands for numbers or constants on the other. And then stuff stands for solve. That's the last thing to solve for the variable. Okay, so on number 1, we don't have any fractions and we don't have any parentheses, so we don't need to do clear the fractions or distribute. When we look on the left-hand side of the equal sign, there's no terms to combine because 6 has a K and 7 does not. So we don't need to combine terms there. And the right side, we don't have any terms to combine there either. Alright, so the next step is the vary part. Get all of our variables on one side. So I'm going to move this 2x over to the right, to the left. And the way I do that is add 2x to both. So I create a 0 pair there. That takes that away from that side of the equation. And I'm left with 6x plus 2, or 6k plus 2k is 8k. Bring down the negative 7, and bring down the negative 7 on the other side. Now I need to get all my numbers or constants on the other. So I need to get rid of this negative 7 on the left-hand side. So I add 7 to both sides, and I end up with 8k equals 0, because negative 7 plus 7 is 0. Then I have to get k by itself by dividing by 8. So k equals 0 is my solution to problem 1. Alright, on problem 1 underneath the target practice, we don't have any fractions, we don't have any parentheses, and there are no terms to combine on either side of my equal sign. So we can go ahead shifting things from one side to the other. So let's move all our variables over to the left. So the way I'm going to do that, since that's positive 2d, I'm going to subtract 2d and create a 0 pair. And if I do it on one side of the equation, I have to do it on the other. 3d minus 2d is d. Bring down the positive 8, and then I bring down negative 7. Alright, then all my variables are on one side, so I have to move my numbers all to the other. And I'm going to do that by subtracting 8 on both sides and creating a 0 pair there. So negative 7 minus 8 is negative 15. So D equals negative 15. Alright, and problem 2, we have these bars, and bars represent X. Okay, and the little units represent, the little squares represent 1. Okay, if we have a little bar and it's shaded in, that's negative X. And then if we have a little unit or a little square with it shaded in, that's negative 1. So on this side, you notice I have 2 shaded in little rectangles, which represent negative 2 x's. And then I have 6 little squares, which represent 6 units. So I have negative 2x plus 6. Well, in this case, I have 3 rectangles, which represents 3x. Okay, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 positive square units, and then minus 4 because I have 4 shaded in square units. So I have 3x, and then 9 minus 4 is positive 5. So the answer to this problem is 3x plus 5. Okay, so now moving on to 2b. We need to remember to take care of our fractions. Well, there are none, so we're good to go there. Then we need to distribute. Well, that means getting rid of my parentheses. So I bring down the 12, I bring down the positive x, and I have to distribute this negative sign into my parentheses. And distributing a negative is the same thing as multiplying by negative 1. So negative 1 times 9 is negative 9. Negative 1 times 3x is negative 3x. And then I just bring down whatever's on the other side of my equal sign. Now I have to combine like terms. So I need to combine this 12 and the negative 9 together. And that gives me 3. And then when I combine my x and my negative 3x, that gives me negative 2x. And then I bring down the other side, 3 minus 2x. Okay, so now I'm going to move all my variables over to the left. So I'm going to add 2x over here to create this 0 pair. I bring down my 3, and negative 2x plus 2x is another 0 pair. So that goes away too. And then the only thing left on the right-hand side is 3. So 3 equals 3 here, which is a true statement. So that means the answer is all real numbers. That's telling me it does not matter what number I pick for x. It will always be true no matter what. That equation will always be true no matter what number I pick for x. All right, on number 3, they're talking. We have two friends, Gretchen and her friend in India. Gretchen lives in Florida, and the current temperature is 69 degrees. And it's rising, which means that's increasing, or a plus, at a rate of 2 degrees per hour. Remember, per means to multiply. So 69 plus 2 times the variable of h. Okay, now her friend in India, their temperature there is 84 degrees. Okay, and it's decreasing. So that one was rising. This one's falling, which means to subtract by 3 degrees per hour. So remember that per means multiply. So minus 3 times h. And the question is asking us, if the temperatures continue changing at the same rates, how many hours would Gretchen and her friend have to talk before the temperature becomes equal? So set those equal to each other. And I'm going to get all my variables on one side. So let's go ahead and add 3h to both sides to get all my variables on the left. So that creates a 0 pair. I bring down 69. 2h plus 3h is 5h, and then I bring down the 84. All right, then I need to get the h by itself, and the first step there is subtracting 69. And remember, that's moving all my constants to the other side. That's the nasty part, my numbers on one side. So I bring down the 5h, and I have 84 minus 69, which becomes 15. So I'm left with 5h equals 15. Then I need to divide both sides by 5 to get h by itself. And h equals 15 divided by 5, which is 3. So it'll take 3 hours for the temperatures to be the same. That's a long time talking on the phone, but that's the answer. All right, problem 3 under the target practice. Mario wants to rent and ride a bike at a state park. There are 2 parks in his area. One has an interest fee of $8 and charges $2 per hour. Well, I told you in class that $8 fee, the fee is always going to be a constant. And then remember, per means to multiply. So, and then 2 is the other. We have 8 and 2 as our numbers. So it's going to be 8 plus 2 times the hours, and that will give you the cost of the first company when he rents a bike. Now the other one has a fee of $2, so that's 2, the constant, and charges $5 per hour. So that's going to be plus 5 times h. And they want to know, after how many hours would the cost of riding and renting a bike be the same? So same means to set them equal to each other. So I'm going to get all my variables on one side and all my constants on the other. So let's go ahead and subtract this 5h over. And when I do that, I end up bringing down my 8. 2h minus 5h is negative 3h. And then I bring down the 2. And then I have a 0 pair, so I don't need to write anything there. All right, so all my variables on one side. Let's get all my numbers to the other. So let's subtract 8 from both sides. I bring down negative 3h, and 2 minus 8 is negative 6. Okay, so now the last thing we need to do to get h by itself is divide by negative 3. So h equals negative 6 divided by negative 3, which is positive 2. A negative divided by a negative is a positive. So it's going to be 2 hours of renting the bike for the companies to cost. At 2 hours, the companies will cost the same amount, depending on which. It doesn't matter which company you rent from if you're planning and riding for 2 hours, because they will charge you the same amount. All right, the last two problems on solving variables on both sides. We've got Claire, who purchased just enough fencing to border either a rectangle or a triangular garden, as shown, whose perimeters are the same. Okay, so let's go ahead and figure out what, and they want to know how many feet of fencing she bought. Well, in order to find that out, we have to solve for x. So let's go ahead and figure out what the perimeter is of this rectangle. Well, we know that this side is also going to be 3x minus 3, and this side's going to be x minus 3. So I combine all my x's. I have x, 3x, x, and 3x. So when you add all those x's up, that gives me 8x. And then I have a negative 3, a negative 3, a negative 3, and a negative 3. So when you add that together, all my constants, that's negative 12. So that's the perimeter of my rectangle, an expression to represent the perimeter of the rectangle. Now the perimeter of my triangle, when I add up all my x terms, I have 2x, 2x, and 2x, which makes 6 x's. And then I have a negative 1 and a negative 1, which makes negative 2. Okay, when I set those things equal to each other, 8x minus 12 equals 6x minus 2. I know they're the same perimeter, so that's what I can use to solve for x. So I need to get all my variables on one side, so I'm going to subtract 6x from both. 8x minus 6x is 2x. Bring down the negative 12. 6x minus 6x is a 0 pair, and then I bring down negative 2. So I have 2x minus 12 equals negative 2. And then I need to get all my numbers on the other side. So I have 2x equals negative 2 plus 12, which becomes positive 10. Then divide both sides by 2. So x equals 5. Okay, but we're not done because they want to know how many feet of fencing did she buy. So we have to plug this number back in up here to one of these expressions we found for the perimeter, because she's buying fencing for one of them. And we just made them the same, so it doesn't matter. So 6 times 5 minus 2. So 6 times 5 is 30, minus 2, that equals 28. So she needs to buy 28 feet of fencing to either enclose this rectangle or the triangle, which have the same perimeter. All right, on 4B, we have the triangles shown have the same perimeter. What's the value of x? So this time, we're just solving for x. And so we're going to add up all my x terms on the triangle. And there's 3 x's. And then I have 3, 3, and 3. And when I add those together, that's positive 9. The perimeter for the second triangle, I have 1x, 2x, and then 2 more x's. So that's 4 x's that I see. And then I have a positive 3 and a negative 3. So that cancels out to be 0. So I created my perimeter expressions, and they're the same, so I can set them equal to each other. So now all my constants are already on one side. My 9 is the only constant that I have. So my variables, let's put together. I'm going to subtract 3x from both sides. That creates a 0 pair. So 9 equals 4x minus 3x, which is x. So x equals 9. Okay, so that's the solving variables on both sides. Now part 3 will be on a separate video, which is going over literal equations.